want to use this video to introduce you to Tropilaelaps. Tropilaelaps is a genus name for a complex of 4 species of mites that live on honeybees, primarily in Southeast Asia. Those 4 species are Tropilaelaps mercedaceae, Tropilaelaps clary, Tropilaelaps connigerum, and Tropilaelaps thai. And these 4 species are natural mites that infest generally the species of large honeybees present in Asia. That would be Apis dorsata, Apis laboriosa, and some of their derivatives. These mites aren't typically a problem for the giant honeybees, but of course in Southeast Asia there are other species of Apis, Apis cerana, and other types of honeybees. And to make matters worse, Apis mellifera, the western honeybee from Europe, stocks were taken from Europe to Southeast Asia, where Tropilaelaps was able to invade its colonies. As a result, we are beginning to learn a lot more about Tropilaelaps and what it's capable of doing to its new hosts. It's a very important mite. I'm going to start with this quick caveat. It is important to know that Tropilaelaps is such a hot topic in the honeybee world that there's lots and lots of research happening even as we make this video about this mite. We know very little about its biology. As a result, there's so much to learn about it and so much new information coming in all the time. I wanted to share that because a lot of what I'm going to talk about in this video is what we think we know about this mite, but as with any new topic, it might change over time. What I do know for sure is this mite does pose a risk to western honeybee colonies. Why is this thing a problem? Well, it's a problem because it gets into honeybee colonies, feeds and reproduces on brood, and that by itself can cause a problem. But it's believed that this mite can also transmit viruses. Think Varroa. How Varroa destructor goes into cells, reproduces on Apis mellifera brood, transmits viruses, these brood can parasitize the adults. Well, Tropilaelaps has a similar, though not identical, life cycle to Varroa destructor. It feeds and parasitizes brood. It possibly can transmit viruses. It will emerge with adult bees. The key difference between Varroa and Tropilaelaps is Varroa will spend time feeding on adult bees, maybe a few days, maybe more, before going back into brood cells to reproduce, whereas Tropilaelaps does not spend nearly as much time on adult bees. It readily goes right back into brood cells to start that reproduction cycle over again. The reason I'm making a video about Tropilaelaps at all is because when Apis mellifera was taken to Southeast Asia, where this mite naturally occurs, it's gotten into Apis mellifera colonies and caused a lot of problems. You see spotty brood patterns, you see dying bees, you see dwindling colonies and possibly greater viral loads. It's a problem once it left dorsata and laboriosa, these giant honeybees, and moved into mellifera colonies. The other trick about this thing is it can co-occur where Varroa is. And when Varroa and Tropilaelaps co-occurs in the same colony, you'll often hear beekeepers and bee scientists say things like Tropilaelaps can outcompete Varroa. Very quickly, Tropilaelaps becomes the dominant problem in the colony compared to Varroa destructor, which is the mite the rest of us think about all the time. Let me speak now briefly about its distribution. I keep saying Southeast Asia, Southeast Asia, Southeast Asia. Well, it's not a thoroughly studied genus of mites. And again, there's 4 species, and probably mercedaceae or clary are the 2 species that represent the greatest threat to mellifera. But because it's not so studied, I'll make comments like it's in Southeast Asia, but we don't know with absolute certainty what its natural distribution is. People are talking more and more about Tropilaelaps because it's being found now outside of Southeast Asia in Apis mellifera colonies. We already were aware of the threat that it posed to mellifera, and now that we see it slowly starting to move out of Southeast Asia, alarms are being raised all around the world to look out for this mite, to be able to diagnose this mite, to be ready for it if it comes, and to be able to control it, hence all the research that's starting to happen. All 4 species of Tropilaelaps are very small. They're even smaller than Varroa. Varroa are already difficult to see on their own, so now take a mite that's slightly smaller, almost always in brood cells. If you know what you're looking for, you can open the cappings of these cells and look for mites in there with a developing bee. But again, these are really small mites. One of the interesting things about Tropilaelaps is that they move so quickly. When they come out of these cells and you see them on the face of the comb, they're just zooming all over the cells, which is not what you see with Varroa. To me, they are colored similarly to Varroa, but tend to be slightly paler than Varroa. Varroa have this oval shape and are elongated from side to side, but Tropilaelaps tend to be elongated from front to back, almost pill-shaped. They're about as long as Varroa is tall. But again, they're so small, and most of their life cycle occurs under a capped cell, from reproducing probably to mating and other things, feeding behavior, etc., that we're still kind of untangling. We're teasing out the biology of this very important mite. We do know that when the host bee emerges, that mite will very quickly go into brood cells to start reproducing again. In fact, some people consider this one of the barriers to the dispersal of Tropilaelaps. The idea is that if any colony has a brood break for any length of time, that Tropilaelaps wouldn't be able to survive that. But new research is suggesting that Tropilaelaps adults may be able to survive on adult bees for 5, 6 days or even longer. With that in mind, a lot of people believe that Tropilaelaps wouldn't be able to overwinter in colonies that give substantial brood breaks, like what you would see in cold climates, where you may get weeks or even months of brood break. Despite all of that, Tropilaelaps is being found in areas that scientists would consider too cold for Tropilaelaps to live. So we're discovering more and more information and learning about them as their distribution is increasing. I do know that a lot of beekeepers will use a lot of the same active ingredients that they use against Varroa against Tropilaelaps. The idea is that it's still a mite, and a miticide that kills Varroa would be a miticide that kills Tropilaelaps. I will say, though, there's increasing research that says that's not a safe assumption to make. Varroa spends a lot of time on adult bees. Therefore, it's vulnerable to a lot of treatments that we could administer to colonies. Tropilaelaps, on the other hand, isn't believed to spend a lot of time on adult bees. It goes right back into brood cells. So any treatment that would have to be used would have to be something that can get into the brood cells to kill the Tropilaelaps underneath those cappings. Know that in your area, if you have Tropilaelaps present, there are probably legal options and labeled options that you can use. Therefore, you would simply reach out to your local bee inspector, your local bee scientist, or your local bee club. These individuals should be able to help direct you to the treatment options that are available in your area. I also know that one of the things that's very popular is the non-chemical control approach of simply creating brood breaks. Keep in mind, I said that so far, Tropilaelaps is not believed to be long-lived on adult bees. As a result, creating a significant brood break of 2 or 3 weeks should kill all the Tropilaelaps in the nest. If they don't have brood to go into to reproduce, they should die. But it can't be just a day or two, which was once believed, because people are finding them on adult bees for 6 days or longer. In my opinion, the 4 species of Tropilaelaps are going to continue to get increasing press, largely because they've got a relatively limited distribution, but where they naturally occur and Apis mellifera has been taken, these mites can cause problems. Apis mellifera is the most popular honeybee on planet Earth. Beekeepers everywhere are concerned about getting Tropilaelaps, but fortunately, because of its limited distribution, we're in the fact-finding stage, which will hopefully ready all of us to be ready should that mite show up where we keep bees. Keep in mind, there's active research, there's a lot of resources being produced available on this mite, and things are changing so rapidly. As we know more about its biology and behavior and its distribution, we'll be able to develop better control methods. As always, if you see something that you're not familiar with, reach out to your local bee scientist, your local bee inspector, your local government official to report it. That might help limit the spread of Tropilaelaps and give you a leg up on its control.